Hey ADF fans, let's talk a little bit today about what you can come to expect from performance within your Azure Data Factory data flows. So I'm going to hesitate to call this true engineering benchmarking. Instead, this is some guidance in the timings, the performance you can expect out of a couple of scenarios, and then hopefully you can use this information to translate this or extrapolate this out for your own data. So I'm going to work with a CSV file first. So we're going to do a data flow that you see on my screen right now, which is a source to a sink with a little bit of transformation in the middle. So I'm doing two things with this data. First thing is I'm going to mask it. So I'm just going to take one of the columns just so I can do some transformation in them so I can mask my employee title. And then I'm going to have down here an aggregate. This aggregate is really to do things like a row count. Now I'm not even going to sync this. In fact, this is going to live off on a separate. Now the sync is also going to be a CSV output. I'm going to just use a data set that is going to land this to a folder. And there's no schema behind it at all. So I'm going to allow Dataflow, I'm going to allow Data Factory to use all the default facilities of Spark to optimize this for me. And this is a good practice to start with when you're tuning the performance of your data flows. So think about general good practices of performance tuning and performance optimizing. We should start with a baseline. In this case, I always set this when I'm landing to a file. I always leave the settings as default so that Data Factory can use the default Spark optimizations and partitioning. Now I do have clearing the folder, so that is an operation that's going to happen before the sync writes the files. This is just going to make it easy for us to be able to see that the files have landed when the data flow in the pipeline seems like it is completed. From an optimization perspective, I'm saying use current partitioning. I'm not setting any partitioning here. And let's see, what else do we want to talk about here? Yeah, so back here, let's have a look at the size and the scope of the data. So the data has 887,379 rows in it, so it's a decent sized data file. The actual size of the file is this lone.csv file right here, and it is 421 megabytes. The number of columns, so we can look at inspect, and you can see the metadata. It is 74 columns within this data, that file. Now I have not set any optimizations here either on the source. This is current partitioning, and that's pretty much it. So I'm just going to let Dataflow, Data Factory, and Spark do its thing. Let's run this. Let's see what we get. So we're going to go over to a pipeline here. Now, very important, the way I'm going to time this for you is that I'm always going to run this from a debug execution. So I'm in pipeline, I'm running from a debug. I'm not going to use a trigger, which means that I'm not going to use the Azure Integration Runtime or any of the compute type settings down here within the activity. Because I'm running a debug, I'm going to use the debug cluster that is set here in this Azure Integration Runtime, which is called Dataflow Cluster. So this Dataflow cluster, the size of it is a memory optimized 80 cores. I have time to live set on it, but we're never going to use time to live here in this demo, so don't worry about that. So obviously the more compute that you apply to your data flow, the better it's going to perform. Let me show you when you are creating a data flow integration runtime where that 80 core cluster sits within the overall settings. So I have set this to memory optimized. Now this is usually going to work better for you because we're in Spark, we're in data frame land, and memory optimized is usually going to work better for you. Compute optimized, a less costly option for the cluster type of VM that we use. General purpose is, just like it says, somewhere in the middle, and general purpose for all different workloads. Memory optimized in most cases is going to work faster. And then for the core count, I have set 80, so I chose 64 plus 16 here, a little bit above the middle of the offerings. You could always go a little bit less, and a very common thing to do is to apply more cores when you have a larger set of data you need to work with, and then change that setting to a smaller IR when you're working with incremental data or data that has a larger time window or SLA that you can work with. So I'm using the 80 core memory optimized. Let's go back to the pipeline now, and we can execute this. So when I click debug, this is going to execute the data flow. So one last thing, let's go back to that data flow activity in the pipeline. We're going to run in debug. Let's make sure that we're using the right data flow. So this is called file perf. There it is, and now we can execute again. We're not going to use these settings down here. We're going to use this debug cluster of 80 core memory optimized. And let's go ahead and run this. Now while I'm running these, I'm going to maybe talk a little bit, let it run in the background for a few seconds, but then I'm going to pause and come back at the end so we can see what the total time elapsed was. I will show you that if you're watching the active monitoring while it is running, some of the things you're going to notice is there will be some acquisition time required for us to get a session with your cluster, and then you will see the data start to execute and start to fill up in the monitoring view until you get to the sync. So it took 14 seconds to acquire that cluster session, and now we're actually executing this code. So I'm going to have the output here in my Azure Storage Explorer. So let me go over to my container, and I'll go to outputs, and the folder I called was perf. This is from a previous run, so remember I said clear the folder. So it's actually doing that now, it's clearing the folder. And then as the data is processing through the data flow, you will see the files come back in. So let me pause at this point. We are at a minute 9, and then we come back when it's done, then we'll see all the files filled up. Okay, we're back and we're done. Took a minute 50 to process the 880,000 so rows with 74 columns of data, 440 or so, give or take, megabytes of data. Let's go over to the Azure Explorer, and we see the files. The files have all now written to the folder. So that is blob to blob. I was using blob store, and that's CSV file to folder, CSV to CSV, and that took 1 minute 50 seconds. Okay, let's go on to the next test, and let's now do a SQL perf. Let's look at taking that same loans CSV file, and let's now load it into an Azure SQL database. So I'm going to point to my SQL database. I'm going to create a new table called dbo.loans. I don't have it already generated. I'm going to ask the Dataflow to generate that for us. I do that by things to recreate the table. So it's going to recreate this table every time that I run this. And I have the same information in the middle, and I am simply just masking some PII, the emp title column. I'm masking it, and then we're syncing everything. So that's it. Again, no optimizations on this. This is just letting Spark and ADF do the thing. And let's go ahead and execute this, and I'll talk a little bit more about it in the background while we run it. So I'm going to go over to my pipeline, and now we're going to run SQL perfs, and that's SQL. There we go. And let's debug this with the exact same cluster that we were using before, which is 80 cores and memory optimized. Now, one of the really important things to make your SQL loading perform very well is to make sure that you have set enough DTUs on your target database. So in this case, I have set it for a premium 500 DTUs for this data flow. It's important to set the DTUs properly so that you can allow enough throughput to your database. So I have this set as a premium P4, 500 DTUs. Normally I run this at a much lower DTU. This is a demo database, and this data flow will take twice as long if I set this to, let's say, 200 DTUs. So it's very important to set that to a high enough number, and you can always scale it back when you're done with your ETL and scale it up when you run your ETL. So let's take a look at that data flow and see where we're at. We were on the actual pipeline itself here, and we can refresh the status, and we're at a minute and 45. Let's take a look at the active monitoring, and we can see that we have actually gone through the entire sequence. So again 887,000 rows from the source, running through that transformation and then syncing that. So right now what it's doing is it's writing it to the database, and the actual time it's taking to write and process is a little over a minute. The actual time it's taking within the transformation is very small, because at this point all the data is data frames within memory in Spark. So when we go back to our data flow, it took a total of 2 minutes and 7 seconds, the pipeline did, from end to end to execute everything and acquire the cluster and to execute the job and come back with a status. If I now go to my database and I select count for my loans, I should see the 887,000 rows on there, and there we go, there's the number, and that was it. So that took 2 minutes and 7 seconds to go from that loans CSV to the SQL data. Alright, let's move on now to SQL Perf 2, and this time we're going to go from SQL DB to SQL DW, or Azure Synapse Analytics. Alright, so in this case what we're going to do is we're going to take that incoming loans table that we created. We're not going to do any optimization on it. We're going to allow the Spark and ADF engine to do its thing. We're going to use read uncommitted as an isolation level, and then when we write to Azure SQL DW to Analytics, Synapse Analytics, we're going to keep all the default mappings. We're going to also keep the optimization as generic. So we will recreate the table, so we'll get a new table generated. So that table is going to be defined here in the sync datasets, and it's going to be called loans DW. So now what we're going to do in between is a couple of things. One is we're going to do a join. So this is creating a very common scenario and getting the timing for that. So we're going to perform some aggregations. We're going to sum up the loan amounts and get the first ID out of through the aggregate transformation, and then we'll join back to itself. It's really a self join, just meant to demonstrate the time that you'd get from a join within your data flow. And then because I'm doing a self join, I'm deduplicating the columns by setting on here that I only want the columns that do not match. So I'm saying skip duplicate columns, so I only get one copy of each column, and then I sync that into SQL DW, Azure Synapse Analytics. Let's go ahead and run this one now. This is SQL Perf 2. Go ahead and run this and talk a little bit about this while this is running. So over here at Warehouse, you'll see that I have set this for 400 DWUs. So again, this is going to have a lot of impact on your performance of your data flows. And again, you could scale up your data warehouse during your ETL window and scale it back down for normal run rate of your DWUs. But the DWUs will have a lot of impact in terms of the performance of the writing of data through data flows, in essence then affecting the performance of your entire pipeline in your data flow. Because what happens is when you look at this performance is it took 18 seconds to acquire the cluster. Then we issued the job definition to the cluster and the executor took over from there. The aggregations and the transformations as they're performing are going to all perform in memory very, very fast. What's going to happen then is the data that actually writes out to the destination, in this case ADW, Synapse Analytics, is going to take time, and so you have to have enough throughput to be able to have that complete within the amount of time that you want your data flow to complete. In other words, this is an area, the sync itself, the actual database, is an area that you can optimize to make this function a lot better. Okay, so right now we're at about 2 minutes, almost 2 minutes to run this entire data flow. This is again 887,000 rows, and we had 74 columns, and the total file size that when we started with this project was 440 megs. Let's pause and come back when this is complete. Okay, we're back, and we completed in 3 minutes and 40 seconds. So to run this data flow from the source of a SQL database to a destination of a Synapse Analytics table, and to perform these aggregations, the join, the self join, and the derived column took 3 minutes and 40 seconds. All right, I got one last one for you. This is going to be SQL Perf 3. In this case, I'm going to again take that same LoansDB source from Azure SQL, but I'm going to load it right back into Azure SQL. I'm going to update that same table, so I'm going to do an update. So we're going to have an alter row here that's going to perform some upserts and updates depending on different values, the grades coming in from the loan data. I also have a derived column to do some calculations on the loan amounts, and I've got a row count that I'm going to send out to a log writer. So this is a very common scenario. So this is getting a little bit more real world scenario style here. This is actually going to also log some row counts and then write that data back to the database and do some updates on it. So we're not going to be recreating any tables here because we're going to be using the same table. We have our key column set, and we're allowing inserts, upserts, and updates. Let's go ahead and kick this one off, and then this will be our final one. This is SQL, and let's go ahead and run this. Now for this one, I don't really have much to add to what I've been saying before. This is going to be using that same Azure Integration Runtime, which is my debug, and that is going to be the 80 cores and memory optimized. Now, one thing I will say while we're waiting is that for all of these, then when you run them in production, and to run and test in production, you need to use a triggered execution with trigger now or create a trigger. In that case, you will incur a few minutes penalty of the Azure Databricks cluster that is managing and executing your data flows in the background to be able to spin up and become available. You can minimize that time by setting a time to live on the cluster. In that case, it'll only take 1 to 2 minutes for the cluster to become available. Otherwise, it will take about 5 to 6 minutes for the cluster to become available. But these timings that we're looking at are all for just the execution of the data flow itself. And we can see that it is running. We did acquire the cluster in 12 seconds. And that right now all of the transformations have completed and takes very little time because they're running in memory and Spark. Now we're just trying to get through to the pipe and throughput of the database, and we completed. So it took 36 seconds to write to the log, and then to the database took 1 minute and 36 seconds. So it takes a little bit longer, of course, to write all those rows. The number of rows that were calculated, 887,000, and we had to write those all out to the database, the 74 columns. Now if we go over to the database at the number of rows that are in there, we see we added a bunch of rows to the updates and the upserts.